and welcome. This video is your ultimate guide to on-grid solar power system installation. We are leaving no stone unturned, covering everything from component selection to final testing. By the end, you'll have a clear understanding of how these systems work and how they're installed. A 10 kilowatt solar system is a significant investment, but it can drastically reduce your electricity bills and your carbon footprint. Let's break down the installation process step by step. First, let's talk about the key components. 1. Solar panels. These are the heart of the system, converting sunlight into electricity. We'll be using Canadian Solar 24 number 580 watt panels. 2. Inverter. This crucial device converts the DC electricity from the panels into AC electricity for your home. We are using a Grovat MOD 1000 KTL3X 10 kW on-grid inverter. 3. Mounting structure. This secures the panels to your roof or ground. We'll be using roof-mounted structures. 4. DC distribution board, DCDB. This houses the fuses or breakers for the DC side of the system, protecting the solar panels and inverter. 5. AC distribution board, ACDB. This protects the AC side, distributing power to your home and connecting to the grid. 6. Energy meter. This measures the electricity generated by your system and in some cases, the electricity you consume from the grid. 7. Cables and connectors. Essential for connecting all the components. We'll be using appropriate gauge cables for both DC and AC. 8. AC disconnect breakers. They protect installers, maintenance personnel, and homeowners from electrical shock when working on the solar system. 9. Grounding. Grounding is a critical safety feature from any solar power system. Proper AC and DC grounding along with bonding protects against electrical hazards and ensure the system's safe and reliable operation. Now let's get into the installation process. Section 1. Panel installation and string sizing connections. First, the mounting structure is installed, ensuring it's securely attached and aligned correctly. Then the solar panels are mounted onto the structure. Solar inverter. The Grovat 10 kW on-grid inverter is a popular choice for residential and commercial solar installations due to its high efficiency, reliability, and competitive price. Here are some of the key specifications. General specifications. Model Grovat MOD 1000 KTL3X. Inverter type on-grid, transformer-less. Phase 3-phase. Recommended max PV power 15 kW max, input voltage 1100 V, rated voltage 580 V, MPPT voltage range 140 to 1000 V, rated output power 10 kW max, output power 11 kW max, efficiency 98.6%, operating temperature range 25 degrees C to plus 60 degrees. Okay, let's figure out how many 530 watt Canadian solar panels you can connect to your Grovat MOD 1000 KTL3X inverter. Panel STC specifications: 580 watt Canadian solar, power output 585 watt, efficiency 22.6%, open circuit voltage VOC 52.4 volts, short circuit current ISC 14 ampere, optimum operating voltage VMP 43.3 volts, optimum operating current IMP 13.52 ampere. 3. Calculating the maximum number of panels. Divide the inverter's maximum PV input power by the panel wattage. 15,000 by 585 Lars 25.64 panels. This suggests you can likely connect a maximum of 26 panels. 4. Crucial steps. Voltage check, string voltage. You must ensure the voltage of your solar panel string falls within the inverter's MPPT voltage range. 140 volts, 1000 volts. How to calculate string voltage? Multiply the panel's VMP by the number of panels in a string. String configuration. You need to decide how many panels you'll have in each string and how many strings you'll have. This depends on the panel's voltage and the inverter's MPPT trackers. Example, you could have 2 strings of 13 panels each, total 26 panels, or other configurations. Ensure the voltage of your solar panel strings is compatible with the inverter. Calculations and considerations. String voltage. With 13 panels in series, the voltage of each string will be VMP 13 multiplied by 43.3 volts. VMP at 562.9 volts. Inverter compatibility. Inverter's input voltage range is 141,000 VDC. String voltage of 562.9 volts falls comfortably within this range, so it's compatible. MPPT trackers. Since inverter has two MPPT trackers and you have two strings, each string can be connected to a separate MPPT tracker. This is ideal as it allows the inverter to optimize the power output of each string independently, even if they experience different sunlight conditions. Your planned configuration of two strings with 13 panels per string is well suited for your 10 kWh inverter. The string voltage is within the inverter's operating range, and the use of two MPPT trackers ensures efficient power conversion. 5. Important notes. Datasheet is key. Always refer to the official datasheets for both the inverter and the solar panels for the most accurate specifications. Professional guidance. It is highly recommended to consult with a qualified solar installer. DC isolator. A DC disconnect switch for a solar string is a safety device that allows you to manually disconnect the solar panels from the rest of the system. This is important for maintenance, repairs, or in case of an emergency. The switch needs to be rated for the voltage and current of the solar string. DC distribution board, DCDB. A DC distribution board is a panel that houses DC circuit breakers, MCBs, surge protection devices, SPDs, and other components to distribute DC power safely and efficiently. Calculating the size of a DC MCB involves determining the appropriate current rating to protect the circuit from overcurrent and short circuits. Here's a breakdown of the formula and the factors to consider. For a solar string with an I short circuit current of 14 amperes, the recommended DC circuit breaker size would be 20 amperes. Here's the calculation. ISK short circuit current, x 1.56 safety factor. ICB is 14 ampere, x 1.56 equals 21.84 ampere. Rounding up to the nearest standard breaker size gives you 20 amperes. DC SPD sizing. For a solar string with 13 solar panels connected in series, each having an ISK of 14 amps and a Vox of 52.4 volts, the recommended DC SPD size would be 1500 volts. Here's the calculation. Maximum system voltage 52.4 V VOC per panel, x 13 panels, a 681.2 volt recommended SPD voltage rating, 681.2 VX2 at 1362.4 volt rounding up to the nearest standard SPD rating gives you 1500 volts. Additional factors to consider. Number of strings. If you have multiple strings, each string should have its own SPD. Isolator switch to MCB connection. Connect the positive output of the isolator switch to the positive input of the DC MCB. Connect the negative output of the isolator switch to the negative input of the DC MCB. SPD connection parallel to MCB. Positive connection. Connect a wire from the positive output terminal of the MCB to the positive terminal of the SPD. Negative connection. Connect a wire from the negative output terminal of the MCB to the negative terminal of the SPD. If the SPD has a common negative, connect it to the negative output of the MCB. Earth connection. Connect the earth terminal of the SPD to the grounding system, earth bar or designated grounding point. MCB output to inverter. Connect the positive output of the MCB to the positive PV input of the solar inverter. Connect the negative output of the MCB to the negative PV input of the solar inverter. Important considerations. Polarity. DC systems are polarity sensitive. It's crucial to connect the positive and negative wires correctly. Reversed polarity can damage equipment. Double check all connections. How to connect a 10 kW AC side grid tied solar system. Now I will cover the wiring from your 3-phase grid supply all the way to your inverter. Warning: this video is for informational purposes only. Working with mains electricity is extremely dangerous. All electrical work should be carried out by a qualified and licensed electrician. Incorrect wiring can lead to serious injury, property damage, or death. Let's take a look at the overall wiring diagram. We'll be connecting our 3-phase grid supply to the energy meter, then to a disconnect switch, voltage protection relay SPD MCB, and finally to the inverter. First, we connect the 3 phases RYB or L1, L2, L3 and the neutral N from the grid supply to the input terminals of the energy meter. It's crucial to match the phases correctly. The energy meter measures the electricity consumed. The output of the energy meter then goes to the input of our 4-pole 100 amp AC disconnect switch. This switch allows us to isolate the solar system from the grid for maintenance or emergencies. From the disconnect switch, the wiring goes to the input of a three-phase voltage protection relay. This relay safeguards our equipment by disconnecting the system if the grid voltage fluctuates outside acceptable limits. The output of the voltage protection relay connects to the input of the AC surge protective device, or SPD. The SPD protects the system from voltage surges caused by lightning strikes or other electrical disturbances. The ground wire should be connected to the designated ground terminal on the SPD. Then the SPD connected parallel to the input of a three-phase MCB or miniature circuit breaker. The MCB provides overcurrent protection, preventing damage from short circuits or overloads. Make sure the MCB is rated appropriately for your 10 kWh system. Finally, the output of the MCB is connected to the AC input terminals of our 10 kW inverter. The inverter converts the DC electricity generated by the solar panels into AC electricity that can be used by your home or fed back into the grid. Remember, each of these connections must be made securely and according to all local electrical codes. Use appropriately sized cables and ensure all connections are tightened to the correct torque specifications. After all connections are made, it's essential to test the system thoroughly. Verify the voltage at various points, check the operation of the voltage protection relay and SPD, and ensure the inverter is functioning correctly. And that's it. You've now successfully connected your 10 kW AC side grid-tied solar system. Again, I must emphasize the importance of hiring a qualified electrician for this work. Your safety is paramount. Thanks for watching. If you found this video helpful, please like and subscribe for more solar energy content. Leave a comment below if you have any questions. And remember, stay safe.